The universe has a beginning, the Big Bang, a fiery origin that ignited space and time as we know it. But if there is a beginning, must there also be an end? While we often marvel at galaxies, stars, and the beauty of creation, the cosmos also holds a quieter, more haunting question. What happens when everything ends? What lies beyond the final flicker of the last star? To answer this, scientists explore the ultimate fate of the universe, and it's a story of staggering timescales, vast entropy, and the slow erosion of everything we know. Let's begin with what we understand. The universe is expanding. Since the Big Bang, space itself has been stretching, carrying galaxies farther apart. Not only is this expansion continuing, it's accelerating, driven by a mysterious force called dark energy. If this continues unchecked, the universe will grow colder, darker, and more isolated. Stars will burn out, galaxies will drift beyond each other's light. Eventually, the night sky will go black, and the universe will enter a phase known as the degenerate era. This era, trillions of years from now, will be dominated not by stars, but by their remnants: white dwarfs, neutron stars, and black holes. The fusion fires of creation will be extinguished, and only the husks of stellar corpses will remain. Even these relics are not eternal. Over unimaginable timescales, white dwarfs will cool and fade. Neutron stars may collide or be swallowed by black holes, and black holes, once thought to be eternal prisons, will slowly evaporate through a process called Hawking radiation. This phenomenon, proposed by Stephen Hawking, suggests that black holes lose mass over time, emitting faint thermal radiation until, eventually, they vanish. It's an astonishing idea. The darkest, most powerful objects in the universe slowly leaking away into the void. In the distant future, this radiation will be the only source of heat and energy in a cosmos otherwise filled with silence. After the last black hole evaporates, a time known as the Dark Era, the universe will be left with only stray photons, low-energy particles, and possibly the faint echo of structure. Time will still pass, but nothing will change. No new stars, no new galaxies, just an endless expansion into cold infinity. This scenario is known as the heat death, or the Big Freeze, the most widely accepted model of the universe's end. It's not a cataclysm, but a fading. A universe that doesn't explode or collapse, but simply runs out of usable energy, reaching a state of maximum entropy. But is that the final word? Other models offer different possibilities. One is the Big Rip, a more violent ending. In this model, dark energy grows stronger over time, eventually overwhelming all forces. Galaxies are torn apart, stars shredded, even atoms ripped into their constituent particles. Space-time itself is pulled apart in a final, catastrophic moment. There's also the Big Crunch, a reversal of the Big Bang. In this scenario, expansion slows and reverses, and the universe collapses back into a singularity. Everything, galaxies, matter, even time, folds in on itself. Some see this as a precursor to a new Big Bang, part of an eternal cycle of cosmic birth and rebirth. Then there's the Big Bounce, a fusion of the Big Crunch and Big Bang ideas. Instead of ending, the universe rebounds, starting anew. This could mean that our current universe is just one in a long chain, each rising from the ashes of the last. Still more speculative is the vacuum decay scenario. Our universe may be in a false vacuum, a temporary energy state. If a more stable vacuum exists, a bubble of true vacuum could form, expanding at the speed of light and annihilating everything in its path. It would be sudden, silent, and unstoppable. Though terrifying, vacuum decay is entirely possible within the laws of quantum field theory. But regardless of the model, the message is clear. The universe will not last forever. The stars will die, matter will vanish, and time may itself lose meaning. This future may seem bleak, but it also carries beauty, because we are here now. We live in what scientists call the stelliferous era, the era of stars, a golden age of light, complexity, and life. An era when galaxies blaze, planets thrive, and intelligence has emerged. At least once. We live in the universe's most luminous moment. That fact alone is a miracle. We have the rare privilege of asking these questions, of studying the cosmos, imagining the future, and pondering our place within it. In doing so, we become part of the story. The universe, through us, becomes aware of its own destiny. And perhaps, awareness is its own kind of legacy. Even if everything ends, even if the stars go out and the galaxies fade, the act of wondering matters. It connects us to everything that was and everything that ever will be. Maybe the end of the universe isn't something to fear, but something to honor, a quiet epilogue to a grand and poetic journey. And maybe, just maybe, the end is not the end.